Good morning, everybody. Welcome. How are you enjoying Star Trek so far? Yay. You're better than that. Come on. People on YouTube are wondering if they want to come to this conference. You got to sell it. For those of you that don't know, my name is Steve Smith. One of the things on the slideshow says my name is Steve Ardalis. I haven't gone that far yet. That was just a typo. But I do go by Ardalis online just because it's really hard to get Steve Smith as a username anywhere. And so that's where you'll find me if you're looking for contacting me afterward, or my email's right there. Today, we're going to talk about modular monoliths and whether or not they are what I'm calling here the Goldilocks architecture. And like any question mark presentation or article, you kind of already know what the answer is going to be here. But it does depend on what you're trying to build, whether it might make sense or not for your specific application, of course. Shameless plug, I do have a couple of courses on Dome Train, which is a new training site that is out there for like the last year or so. It actually just had its birthday last month. And so if you're interested in learning more, you can find these courses there. And with that, let me just start in on the actual talk here with a little bit of software architecture background. So software architecture is something I've been interested in for a long time. There's an excellent book called The Fundamentals of Software Architecture, and I recommend you check it out if you're interested. And one of the things in that book, it talks about the first law of software architecture is that everything is a trade-off. Right, and so like there are no good or bad architectures or right or wrong architectures. There's just more and less expensive architectures, really, and whether or not it's going to be well suited to your application. So one type of architecture, probably the simplest type of architecture, is what we just call a monolith. Right? And so what distinguishes this from other kinds of architecture is simply how it's deployed. Right? It is a single unit that gets deployed. And even that's kind of a misnomer, because most of the applications that we build, if it's just a simple, web application or web API, and we deploy that, we probably also have a database, right? And so it's already a distributed system, even at the beginning, if it's talking to a separate database. But leaving that aside, right, it's the simplest in terms of the number of moving parts that you need to ship or maintain or support or any of those things. And so the issue that you run into, though, with the traditional monolith is that it doesn't always get maintained well in terms of modularity internally. Right? So like logically and physically, it's a single unit, but internally, we would like for it to have some modularity so that we can replace things or swap in different features or things like that. And that's where things often go badly. And you can end up in this big ball of mud situation, which is best avoided. Now, there are things worse than a big ball of mud monolith. We'll get to that in just a minute. But it's a place you don't want to be, and it's a place that a lot of my clients are in, and so I have a lot of experience with helping them move toward modern, more modular, more distributed, logically distributed systems. Okay, so on top of the monolithic architecture, which is really just saying you're shipping one thing, a frequent approach is to use what's called layered architecture. And layered architecture, most of you familiar with. It looks like this, and it improves the design of the monolith from having everything just being mixed together to now having these different layers that each have responsibilities. And so you separate out the code by its technical concern of UI or business or data or whatever it might be. And then these might be separated further into different projects or different assemblies. But at the end of the day, when you publish your application, you're still publishing all of those assemblies to the same location. Or if you're a .NET developer, you'll have different DLLs, right? Or jar files for Java or whatever it might be. And so there's a problem that you may have encountered and probably have with layered architecture. And so you imagine that you have a system and it has a number of different features, users, carts, all those things you see across the top there. And as you're building this out, you've used layered architecture. And so the user interface, let's say, is the top line, and it calls into your business layer, and it talks to the data layer. And that's beautiful, and it's great, and everything's well separated, and it's easy to maintain. But then you add another feature, and of course, the shopping cart needs to go get information about the user, and then do stuff with cart and store that. And then you get orders. Well, it needs to get the contents of the cart in order to do its job. And maybe it needs something about the user too, like their default shipping address, who knows. Of course, it's got some business logic, and it stores its stuff in its own place. And then maybe it also needs to check inventory as part of that process as well. And it'll just do that with a database call, because why not? I'm already there. And so then inventory is its own separate thing too, but it also maybe needs to check orders to see what's pending, and there's some more crisscrossing of lines there. Shipping might have to touch all kinds of stuff as well. And so what you end up with is, if someone comes along later and they want to split something out, and they say, we should take orders and make that a microservice, right? Well, now there's all this cross-cutting stuff that makes that really difficult, right? And so you get this tangled mess of what turns into spaghetti code, even though you've got all these layers, right? So at best, because you've layered it, you've got lasagna code, right? And so it's not good, right? It's better than spaghetti code, but it's got its own problems, right? And so what you want is modularity that isn't strictly by technical concern, and that lets you do some cool things. Like you can integrate these different modules using certain patterns and interfaces so they can still talk to each other, because you need that. You can have it provide better encapsulation, so each module can hide its internal workings from other modules. This is important for decoupling, right? To keep things loosely coupled, so that you're not just reaching into the database that some other module is using, for example. It makes it's useful because you're looking at it on a feature-by-feature basis instead of looking at it horizontally as these layers. And then finally, you want to include everything in the module so that it is standalone, so it's independent. Now, all of these things may sound familiar to you as like microservices, right? Like this is how microservices should be built. And in fact, there's quite a bit of similarity between microservices and modular monoliths, because they both require that modularity. Okay, so the solution here is to build separate modules that cover the whole stack of technologies for each one of these different features. And when you do that, then you have a much more robust architecture, because you can swap these things in and out. You can expand one. You could take one of these and say, hey, we need this to be a separate scalable thing, so we're going to pull it out and make it its own microservice, or not, right? You can make that decision on a per feature basis or per module basis once you go down this path. And so, like, why don't we just do microservices? Well, you can, and a lot of folks do. And the thing that they have found is that microservices are very expensive. Right? They're expensive to build correctly. There's a big learning curve. They have way more things to deploy, which means it's more difficult to get your CI/CD and your DevOps working. They're difficult to host. They can be expensive to host. You have to learn about things like Helm charts and Kubernetes and infrastructure as code and a host of other things that if you were just building a monolith, you would not have to worry about at all. And then just diagnosing them is a whole ordeal as well, because there's so many different moving parts. When a single request comes in, it doesn't just have one thing that you could step through in the debugger and you're done. It may have a dozen different services all coordinating somehow to respond to that request. And so being able to troubleshoot when something doesn't work right can take a lot longer. Not to mention that it's often difficult to set these up locally. So if you've got a bunch of microservices and they're all being managed by different teams and they're all being shipped at different times because they're independent and they can, which is what that's how they should work, then getting all of those current versions or specific versions that are now in production running locally on your machine or in a particular environment is its own set of challenges. Right? So all of these things are surmountable, right? And plenty of companies are shipping things with microservices today. How many of you are doing so right now? Yeah, a bunch of you, great. And so I'm not here to say that microservices don't work. I'm just saying that microservices have trade-offs just like other architectural choices do. This is something I posted a few years ago, so in 2020. And the guidance that I like to give is that if you're building a net new application, a greenfield application, it's a good decision for you to start out with a modular monolith. Initially, you probably just start with a monolith, right? But once it gets big enough that there's some complexity, or you want to throw more people at it and have different teams working side by side, right? Having a modular monolith makes a lot of sense as the next step. And of course, Joey thinks we should just go right to Kubernetes, right? All right, so don't just listen to me. Let me appeal to authority here. So Martin Fowler also has an article from 2015 where he basically says the same thing. It's build the monolith first and get that working correctly. Hopefully build it modularly, because otherwise you're going to have this tangled spaghetti code thing, and good luck peeling away microservices out of that. But if you can do that, if you can demonstrate that you know how to build things in a modular fashion with the monolith, you can move a lot faster while you're doing that. And he goes on and has this great graphic that I liked, as it's got dragons in it. And he says, if you try and just go straight to microservices, right, that path has lots of risk. Whereas if you start building a monolith and you build it with modules, and then you find that this particular module would be great as a microservice, so you spin that off as a microservice, right? That's a much less risky way to go forward. And I've seen that to be true as well. Now, I will say that there's another article on his same website written by someone else that says don't do that because you'll never be able to build a modular monolith, and it'll just be a tangled mess if you don't start with microservices. But I agree more with Martin Fowler, so I posted his here. All right. It's not the case that more things are always better, right? So if you can't create high-quality monolithic code that's modular and easy to maintain and does its job well, it's unlikely you're going to be able to do a whole lot of little things with microservices any better, right? So first, figure that out. And then with microservices, there comes a lot more complexity. Just trying to figure out all the things that are running and what versions they're using and what versions their messages are using can be a challenge. Right? If you have a monolithic application that's all running on a single thread in process, it's really easy for you to just step through and see exactly what's happening. All right, so the thing you really want to avoid is the distributed ball of mud or distributed monolith. There's a great talk, you can find it on YouTube by another speaker, I don't think he's in here, but Jay Tower talks about avoid building the distributed monolith. If you want to see all the pitfalls of what not to do when you're building your microservice, go check that talk out. It's excellent. But this graph here that kind of shows you between modularity and how many services you've deployed is a useful thought exercise, because I'm saying that you probably want to start in the bottom left, and every brand new application does, because you start with that first line of code where you just say hello world, right? That is a single thing at that moment until you build more of them. And then you have choices, right? Do I keep building things in process in a single deployable, or do I need to have more things running in other processes? All right, so when you make a decision that you're starting, let's say you're in the bottom left, and it is a ball of mud, there's no modularity, and you've decided that we need modularity, we need all the things that brings us, right? We want to move. A lot of times the decision is, let's go to microservices, because that'll fix all the things. And so I'm suggesting that you don't necessarily want to move in two directions on this graph at once, right? So you can move from no modularity to having modules with one step, and then move to having microservices on an as-needed basis as a second step, if you need to. There's a big learning curve in both of those, right? So if you go from just a monolith to a modular monolith, you have to learn how to do that and what's involved and how your code's going to work and run and communicate. And then when you go to a distributed system, you've got a whole host of things you've got to learn about that. The thing you want to avoid is moving down then to the distributed ball of mud, distributed monolith. That's the worst of all worlds, right? Now you've got all the problems of a distributed system, and everything is tightly coupled together and has to be deployed at the same time, and you're still getting called at 3 o'clock in the morning because things are on fire, and it's not a good place to be. All right, so you want to move up first and move toward modularity. Then if you want to embrace the distributed architecture pieces, and we'll talk about some of those in a second, just don't try and do both at the same time, because it's just way more things that you have to learn all at once. Distributed systems have their own problems. There's a great quote here. It says you can have your second computer once you've proven that you know how to use the first one. And the other rule of distributed systems is don't distribute your system until you have a good reason to, an observable reason, not just because you read an article that said microservices are cool. All right, so why wouldn't you build a distributed system? Well, there's this thing that you've probably heard of called the fallacies of distributed computing. And I could do a whole talk on that, but quickly, there's things like the network is reliable. It isn't always, right? So you need to know about retries, right? Latency is 0. Well, it never is, right? As soon as you do network hops, things are a lot slower, and that can add up. Bandwidth is infinite. It's not. So things like how large of an object you're pushing around, how big those messages are being sent between different services starts to matter. The network is secure. It might not be, right? So like what type of information you're going to send over the network starts to be the thing you have to think about, where maybe it wasn't so much in the monolith in memory. Your topology doesn't change, right? However it's all structured right now, it's fixed, right? So everywhere in your code, you can just use the exact IP address of each thing you're talking to, right? Probably not. That might change. So you need to have some way to rediscover where things are now. There's only one administrator for the entire network. That may not be the case. You may have multiple divisions, multiple different networks intercommunicating with one another. The transport cost might have costs, right? Transport costs might not be free, right? There might be transport costs. So when I'm talking between two methods in a .NET assembly, that doesn't cost me anything, right? Azure's got a lot of things that they'll charge you for. They haven't figured out how to charge me for that yet. So when I'm trying to put stuff in and out of a message bus or local, or not local, blob storage or something like that in a cloud, right? Every single thing I do is going to have some cost associated with that. And then finally, that the network is homogeneous, and there's no different types of things that you're having to communicate with, maybe using different protocols or things like that. All those things you don't have to worry about at all if you're just staying with the monolith, and that is getting rid of a lot of trouble that you may not need. All right, so let's not forget all the other things that you have to worry about, and there's more than just on this list, right? If you've built microservices, you know there's a lot to it, all right? And so why don't we just have the modules be in the monolith? And so a modular monolith might have a structure that looks like this. And this is very similar to what your microservices architecture might look like, right? We're going to have a host, which is kind of analogous to an API gateway, and it's going to be the thing that users interact with. That's where requests come, and we handle them, we perform routing and things of that nature. And then we're going to have the separate modules, right? And each module is going to be a part of the same solution in .NET parlance, but it's all behind the host, right? And the host can communicate with each module. The modules, importantly, don't communicate directly with one another. They have to go through some intermediary to do that. But with this relatively simple structure, you basically, to add a new module, you write that module, it's got its own UI, business logic, database, whatever, and you just kind of plug it in, and you do whatever you need to in the host to wire it up and let it know about it. All right, so your modules should be logically separate, they should be independent, so they don't depend directly on one another. If you update one, it doesn't mean it breaks all the other ones. Just like microservices. You can work on them with separate teams. Going down this path immediately will make it so you have fewer merge conflicts. If you have a big spaghetti code monolith and everybody's checking in and there's hotspots where you're always changing things, this will eliminate a lot of that because you could have a team per module and they're never going to step on each other in separate modules. They should be feature specific. They should represent a bounded context. So that's a domain-driven design term. And what it means is that there's this boundary around a space in which you are talking about a certain thing, a certain concept, right? And so it's the ticketing bounded concept or bounded context. And within the ticketing bounded context, there's certain things that are true. There's certain invariants. There's certain language we use, right? Inside of ticketing, we give tickets to customers, and customers go to an event with their ticket, right? But somewhere else in a different module, they're not customers, they're users, or they're owners, or they're something else, right? So the language and the model that we use for the problem is going to be different between different bounded contexts when we build an application using domain-driven design. And it works really well with modular systems, whether that's microservices or modular monoliths. You generally want to have a one-to-one mapping of a bounded context to one of those modules. They generally should have their own persistence mechanism, right? They should own their database. They should own their data store. And so that makes it so they can be more independent. One of the things that will make your microservices turn into a distributed ball of mud is if you have all of them sharing the same database. Right? Now you can't change the database because you might break some of them, and that makes it really difficult for you to evolve the design. Also, if the database goes down, all your microservices go down, right? So you have this single point of failure, and there's a host of other reasons why you don't want to have the database shared between microservices. And the same is true for your monolith. Now, that doesn't mean you have to have a separate actual physical database for everyone. You can just use something like a schema to say that these are the things that are owned by this module within the database, and that works perfectly well. And there are times when, for performance reasons, you may want to punch a hole in that encapsulation that you're getting and decide that you want to do a transaction across two different modules or run a report that targets data on two different modules. Generally, you don't want to, but you have that ability if you're just using schema on a single database. You can organize them differently based on their complexity. So you don't have to follow a one-size-fits-all way of structuring those modules. And what I mean by that is, how many of you use like ports and adapters or clean architecture or something like that for your stuff? Some of you, or how many of you use like vertical slice architecture and have simple vertical slices through your code? Or how many of you just YOLO and do whatever feels right at the moment? Yeah, that's good. So with these modules, you can do any of those, right? One module is like, it's just simple CRUD. I don't need domain-driven design. I don't need all this extra weight and abstractions and dependency injection and all that. I'm just going to hard code it all and make it super simple and just generate some screens or whatever, right? And it's admin only and nobody else is going to see it, and I just need to ship it by Friday. And then you have this other part that's like super complicated, the company's depending on it, lots of business logic. There, maybe domain-driven design makes sense and some more testing and some more abstractions. And you can fit for purpose how you structure the code in the module based on that. And so these are basically all things that microservices should also have. So you're basically taking your microservices and you're saying, you know what, I like what you're doing there, but I don't like the fact that I got to hop all over the network to do it. Why don't we bring those things into the same memory space, and we can do all those same good things from microservices, but right inside this one assembly. All right, so how do we get there? Well, there's a few patterns or tricks that you want to use in order to keep the modularity happening, in order to make it so it's difficult for things to cross-depend on one another. And so one of the things that I use heavily is the internal keywords, like public, private, protected, those things. Right? One of them is internal, and in .NET that means that you can't get to it from another assembly. All right, so if I mark all the entities in one module as being internal, that means no other module can suddenly depend on those or new them up or work with them. And that allows me to have that encapsulation where I don't have cross-dependencies between the modules. You can also just look at the references between the projects and say, well, this project should never depend on that project, and that helps too. Now, they are going to need to talk to each other, and I'll show you how that works in just a second. I already mentioned they should own their own data. The modules should then expose public contracts, right? And so the way I make this work in the .NET world is I have a different project that has these public contracts, and these are going to be interfaces and DTOs. That is the way that other modules can communicate. Now, if you had just two modules and they were just class libraries, and we did let them just talk to each other, the other problem you would run into is circular references, right? Because you can't have module A depend on B, and then B depends on A. Your tooling will blow up and say that's not allowed. As soon as you introduce a third library, now it works fine because both of them can depend on the library, or each of them can depend on the other one's library, and that works perfectly well. Modules should generally communicate indirectly, and I already mentioned that, but there's a couple different ways. The main one for fast in-memory communication is going to use the mediator pattern, and then you can also use out-of-process things just like you might with microservices using RabbitMQ, Azure Service Bus, SNS, whatever your message bus of choice might be. Okay, so here's two modules, the blue one and the orange one. And they each have contracts. And if the blue module A wants to talk to the orange module B, right, it's going to reference module B's contracts project where it's going to find the types that it needs, because C# is a strongly typed language. And it's going to use a mediator to do the work of sending the message to module B in a way that module A doesn't need to know about module B directly. Right? And so that's the trick that lets us have the loose coupling between the modules. And so what that looks like is something like right here inside of a cart checkout use case or service. It's going to create this command. Well, that command is coming from the contracts project of the orders system. And then it can use mediator to go send that command and then wait to get it back. Right? And it works fine for commands. It works for queries. It works for events. Right, so any of those types of messages that you want to send around, you can do in memory using a NuGet package like Mediator or Mass Transit, or you can roll your own. There's a bunch of ways that you can do that in the .NET ecosystem. All right, so let's compare. We've got modular monoliths, which are logically independent, but they're physically deployed together, whereas microservices are physically independent. Monolith is going to be easier to deploy, cheaper to host, easier to troubleshoot. It's less scalable, right? So this is one of those trade-offs. You can scale monoliths quite well up, right? Add more hardware, give it a better processor, throw more memory at it, and out, right? You can have a bunch of them, right? You can have a web farm if you want, but you can't just take the cart module and scale that independently, right? For that, you need microservices. But it turns out that you probably don't need that scalability of every individual component for all your features. There's probably only a few of them where it makes sense, and you'll know what those are after you run the thing for a short while. And so maybe you start with the modular monolith, and then you figure out that, hey, the shopping cart thing is a hotspot. Let's make that a microservice, and everything else can still stay. And so that's a perfectly valid way to do a hybrid architecture where you evolve things that need to be their own microservice once you have data that suggests that should happen. The monolith can be less available, and what I mean by that is if part of it blows up and fails, it's a single process, so the whole thing goes down. Whereas with microservices, you might have one service that's not working, but everything else is still okay, and so you might have some partial uptime still. And then generally with your monolith, you're going to be restricted to a single platform. So if you decide you're going to build this thing in .NET, well, then it's all going to be in .NET, right? There's not going to be one module in Ruby and another module in Python and another one in Java, whereas with microservices, you could do that. And in fact, some companies do that, and some companies even regret doing that, because then later on, if they want to consolidate and be able to have team members that can move around between their different services, it becomes much more difficult because they've not standardized on a platform. But it is an advantage that you have that choice. All right, so let me pause for a minute before I start showing some code and just ask any questions about any of that so far. Sean?
When you're building your monoliths, your modules, sorry, when you talk about the UI tier, are you talking about like at the API, or are you talking about micro front ends, or what does that look like?
So the question is, what does the UI look like if it's, this is being hosted on the server? Is it APIs only, or is it micro front ends? I am not a front end developer, so I know that things like micro front ends exist, but I don't have any idea how to set them up. So for me, it's going to be all server-side stuff, and I know how to do that with MVC or with Razor pages or with APIs or any of the .NET stuff. You can split module by module and put it in separate libraries. I've done stuff with Blazor for the front end. I haven't tried to make it super modular like this, but I believe it's possible because I'm pretty sure you can put Razor components in different libraries and stitch them all together. So what I see happening and the way that I would expect this to work is that the back end would be modular monolith, and then the front end usually has its own separate build process anyway. If you're building it in a separate language, like you're building it in React or in Angular or something. And so there you could have modules that correspond to your back end. And you may have other patterns that you're using, like a BFF, back end for front end, pattern for your smart client to talk to, whether that's a mobile app or a single page application or a SPA. So yeah, generally for me, it doesn't include the front end UI client. If it's a rich client, it is going to be just the API, which is what I'll show in the demo. But I do think that you certainly can have parallel modules where you've got the rich client modules talking to their corresponding features in the back end. Good question. Others? Cool. All right, I was perfect except for Sean's question. All right. Let's look at some code, and I just realized I want to make this bigger because I always forget that, so let me do that. And can you see? No, that's tiny, isn't it? Yeah. All right, we're going to make this way bigger. It's already 16. Is it good? All right, cool. Oh, sweet. You guys are rock. All right. All right, so here's a sample solution. This is called River Books. Imagine if a bookstore decided to name itself after a river, and that'll give you an idea of this demo. And so the web front end here, this is the host that I mentioned, right? And so if we look at this, if you're familiar with .NET applications, right, this is an ASP.NET Core app, and in here, it just has a few references to a handful of packages. I'm using fast endpoints, which is a way to do minimal APIs in a really nice way where each one has its own class and you have a separate request and a separate response. You'll see that in a second. And then it references all the different modules here. But there's really nothing else here, right? So there's program.cs. And the most important part of this is this section right here where we add the modules. And so for each of the modules, there's an extension method that lives in that module that basically this thing hooks into, and it wires up whatever services, whatever things that module needs. And so that's the only thing really that you have to add that's module specific inside of the host. There's other ways that you can do this. You can do it with discovery using reflection, so that you don't have to even add this extension method. And it's up to you which one you prefer. Right? This one's nice because it's really obvious and you can see it. The other one's a little more magic. But I have another demo that I'll show you what that would look like. And either way, like the whole intent is that there's a minimal amount of work to plumb in a new module in the host, and after that, all your work is in the actual module. And so if you were ever going to get a merge conflict with multiple teams or whatever, this would be where it is like right here on this line. If two teams are trying to add a module exactly at the same time, then yeah, you might get a merge conflict there. But absent that, everything else should be happening inside their own separate modules. So looking at these modules, we have a books module, and inside of that, the module itself is there's not a Visual Studio or a .NET thing for a module. So I'm just using solution folders, right? And so up here, it's logically a module, but really it's just these libraries that happen to go together. And so there's a books module that is the actual module, and so inside of that, you're going to see it has UI stuff with these endpoints. It has all the data connections it needs. In this case, this was using Entity Framework and talking to SQL Server. It has integrations, And that's the term that I use for things that integrate with other modules, right? And so this is a handler for a query that's coming from another module, and I'm putting those separate because they're not really part of the domain in DDD, parlance. They're really there just to allow me to integrate with other modules, and so I want to keep those kind of in their own place where it's easy to find them, and I don't let them, kind of corrupt the rest of my design for the system. And then everything else in here is just stuff related to the books. So books have titles and authors and what have you, and it's not really that interesting here. The extension just looks like this, and let me get this out of the way. And so in here, we're just wiring up the services that we need, and then we also log something out to say, hey, we registered all these services for this module. And that lets you know when you start this thing, like you can see this module's there, like they're giving you all green lights that they're working, which I find helpful. Okay, so then what's in contracts? Well, contracts is the public thing that you can see, right? So you can see this is public. Other modules, if they need some information about a book and they don't have it, they can just send off a query. In this case, it's going to use Mediator. And this is where they get that query. This is a public thing that they can have a reference to. Any module can reference any other module's contracts project, and there won't ever be a circular dependency because the only thing the contracts module depends on is its underlying module. Right? So this one depends on books. And then you might have tests, right? And so I put my unit tests and everything, and integration tests and what have you, all inside a test project as well, right? So that's kind of my organization. So within that solution folder, everything is together. The other modules in here, there's a user module, so it's got all your authentication and stuff. And for whatever reason, I decided to put all the shopping cart stuff in here too. So there's shopping cart endpoints are in with users. And so when you go to add an item to the cart or you go to checkout, like occasionally you're going to need data from other places. And so I was showing you on the screen the checkout method that was doing the check to go create the order in the PowerPoint. So this is an example of fast endpoints. This is the UI layer. So you'll see there's very little code here that's doing any type of business logic. And so all it's doing is getting a checkout command, checkout cart command, which is local to this module, and sending that to another use cases handler, which I'll show you in a second. And then it just takes whatever status and returns it. So super simple here. One of the things I really like about the fast endpoints library, it's very similar to one I had that was built for MVC called API endpoints. Both of them use the Reaper pattern, which is request endpoint response, REPR. And so it's a way of organizing your APIs so that each API has one endpoint and optionally a request and or a response. And so you can see that right here on this class definition that this is the request that it gets, this is the response that it returns back, then this is the endpoint. And so unlike controllers, you don't end up with this thousands line long thing that has all these action methods and 20 different dependencies injected that any endpoint only uses one of. It's much cleaner. It's actually as fast as, if not faster than, minimal APIs as well. So it's not my library. I don't get anything for saying that I like it, but it is a really nice library. So then it calls into use cases, and there's a handler here that says, hey, I know how to get information about the user, but also we're going to need information about the cart. In this case, we're going to create a new shopping cart order. Sorry. And so that's right here. And so after I go and I get all the stuff that I need from locally in my module, I'm going to communicate with another module using a command in this case, and then sending that with Mediator in this case. So that's where this result comes from. This is using another pattern called the result pattern. I have a NuGet package called rdallas.result, and basically it's a simple generic wrapper around whatever your return type might be, and it gives you things like, was it successful? Or was it not found? Or was it not authorized? Or was it invalid? And so for any return type where you might have been tempted to throw an exception to reflect failure, you can instead just return a different result. And then that translates really nicely into HTTP verbs, it turns out. So that works well. This thing is then also going to do another thing where it's going to send an email to the customer and let them know that they bought something. And that's, again, just another Mediator send away. So the way that it's integrated with other modules in each of these cases is using the Mediator pattern. All right, so let me run this real quick so we can take a look at it. And it's the UI that I'm going to use is just Swagger or HTTP. Good, way over there. All right. So let's start here, right? And we can just say, hey, give me a list of all the books. Oh, actually, no, let's start here. There. All right, so can I make that bigger? There we go. So you can see when this starts up, you've got all the modules registered. It tells you that, registered all these endpoints, some background services are doing things, and then, other logging will keep happening. But, this part right here, I find to be super helpful because you know that everything's wired up correctly, and, it's easy to see if you forgot or something broke where something didn't get registered up. Okay, so then, all these things are going to hopefully work. Maybe. Maybe not. It doesn't need Wi-Fi, it's local. Yeah. Okay, it's just really slow. Oh, there we go, 500, blah, blah, blah. Oh, you see, okay, fine. All right, that may be a problem. All right. I'm gonna fix that in a second, but let me show you a different demo first then. So over here, the thing that you have to do when you create each one of these modules is you've got to create a solution folder, and then you have to go and add each one of those different projects, and it's kind of tedious. And so a friend of mine actually created a template for this, so you can just do a .NET New template, and it's called productive.monolith, and modular monolith. And so this lets you then have these two templates that you can use. And let me just jump to a Scratch folder. And then somewhere I've got some demo code that I can copy paste like this. All right, and so all this stuff's in the README for this package, but we'll just create this new thing right here. And it'll say, hey, it was created successfully. Look at that. I can console write line. Oh, but it failed. Oh, yeah, that needs Wi-Fi. All right. Yeah, I can fix that. One sec. You can't do anything without Wi-Fi these days. It's darn NuGet. I could have a NuGet local feed, I suppose, but do it.
What's your phone's password?
It's right here. Yeah, okay, let's try this again. Well, it probably actually created a folder or something that I have to clean up now, so it's, yeah. Cool. All right, let's try that one more time. I feel like that the template was created successfully might have been premature, since the last time it told me that too, and then it said, but no, not really. All right, so now let's look at that. And let's do that. All right, and so in here, what this has created is basically the entry point, which has your program.cs, and this one actually will auto-discover and register all the modules. So it's got some code in there that's going to use reflection to go and look through and see which things have the types it's looking for, and then it wires everything up for you. So you don't have to have the other approach I showed. And so that's all just in here in this extensions method. And the nice thing about it, well, let me talk about shared kernel also. So shared kernel is another domain-driven design concept where things that should be shared between different modules go into this explicitly named project or library that they call shared kernel, and then you don't change that unless all the teams that are supporting all the different apps that depend on it agree, right? And so you try not to yank the rug out from everybody because this is stuff that everybody's depending on. And so this doesn't have a lot in it to begin with, but it's a place where you could put more things that you wanted to share between modules. All right, so then if we want to add another module, that's the part that's kind of nice. We go back over here, and we're going to say add a new monolith to eShop, like that. And we paste it over here. I'm in the right folder, and it says no. I took that right from the README file. Why is that not working? Invalid options. All right. Thought I took that right from the README file. Let's go over here. This one. So the library is at GitHub david-acm/monolith, and it says, I wonder if they just changed it. that it looks like that, right? Pretty sure that's what I did. I'll go right there. That's what I did. Yeah, it's going to give me the same error. Yeah, all right. So this worked when I tested it, but you know, demo gods being what they are. It was supposed to be in the eShop. Look, like right here it says, go over here, go over there, over there. It says right there, change into that directory. But maybe that changed. Sir, let's try it. Because now, no. All right. Sorry about that. Good idea though. I like your spirit. Yeah. But when it works great. And you know, I'll file an issue. But the idea is that it would create the extra things for you, right, and save you some typing. It's not that hard to create a solution folder in a couple libraries, but it does get tedious if you do a lot of them. All right, so coming back to Visual Studio here, let me jump around and show a couple more things. So inside of this particular solution, what I wanted to showcase with this is that it doesn't just work for relatively simple CRUD things, but you can use these different types of modules for other more difficult tasks, right? So scheduled jobs, background processes, reporting, things that aren't just simple CRUD operations necessarily. So for example, to do email sending, this is a separate module. It's using background worker to send the emails on a periodic basis. It's using another pattern called the outbox pattern, and it's using MongoDB. So for it to do its task, I've got MongoDB running in a Docker container, and it stores emails that it is going to send in MongoDB, and then after it has sent them, it adds to that record and says, here's when it was sent, right, and other metadata. And so basically, the idea here is that within each module, you can make decisions that are appropriate to that module. Now, I don't know why I would want to use MongoDB for that purpose, but I can, and so I did just to kind of show, like, this is what you can do. So in this one, there's all the MongoDB settings are in here. The work of talking to the database is all encapsulated in here. And so there's not any dependency on any framework core or SQL Server or any of the stuff that some of the other modules are using. And so in here you can see that instead of configuring Entity Framework, we're configuring MongoDB, and it's got its own set of dependencies. Let me talk briefly about the outbox pattern and different ways that you can use it. Outbox pattern is nice because you often run into scenarios, especially in a distributed system or any modular system, where something could fail and then you still indicate success somehow, right? And so it's all about basically having a transactional way to deal with failure. Imagine that you have a shopping system like this one, and somebody goes to place an order, and the order fails, right? Doesn't succeed in writing to the database, but the email that says, hey, thanks for your order, that succeeds, right? And so we send them an email that says, hey, we got your order, but then we have no record of the order. And so when they call us, we're like, oh, it's not in our database. That's the scenario you don't want. And so to make it so that that is way less likely to happen, what you can do is you can take your email sending and your order and put it in a single transaction. And you can't actually put sending an email in a transaction because that's a separate thing that's outside the database, but you can put the command to send the email with all of the information it needs into a table in the same database where you're storing the order, and you can put a transaction around that, right? And so now that whole thing succeeds or fails, and so if the transaction fails, then none of it gets in there and there's no email to send, but if it succeeds, then there's a row in there that says, hey, there's an email to send, and some other process is watching for that and picks it up and sends the email. So that's one way that you can do it. You can also do it on the other side, where the thing that's getting in the commands to send the emails can also just queue them up into an outbox and then periodically send them. There's reasons why you would do that too. The biggest one is for performance. You never want to have your users waiting for you to send an email, right, as part of a request. So like a company that does this really well, you may have heard of them, called Amazon. How many of you have bought anything from Amazon? Anybody? A couple, yeah. All right, so when you shop at Amazon and you check out, you see the page comes back really fast because they're great at this, right? They got a million microservices. And the thing that comes back and it says, hey, thanks for buying all this stuff. Here's what you bought. Here's when you're going to get it, yada, 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 right? Yeah, okay, right? Well, no, not usually, right? Usually what you get is something like instantly comes back and says, we got your order, right? And then you get an email real soon after that says what happened, right? And if there was a problem, right, do you ever get a problem on Amazon when you go to check out that says, sorry, your card was declined, sorry, your shipping address doesn't work, sorry, the thing's on back order, right? That never happens when you're waiting for the checkout button to come back. That happens instantly, right? Because they don't want anything to come between divesting you of your money, right? And so they will take that order no matter what, right? That's a cannot fail ever operation. And then they'll figure it out later, right, on the back end. Like when we went to try to charge your card, we found that it didn't work, so fix that, please. But they'll do that by email. They'll do that async. And so there's obviously good reasons to do that, and it can certainly help your customer experience, your user experience, to not have things that are waiting. And building distributed systems or modular systems gives you a nice way to do that because you can do things like this outbox pattern where it just goes into a queue and eventually gets sent. And so in here, there's this background service, and it's checking for the emails to send and doing its job, and there's sending it with MimeKit, et cetera, et cetera. So that's pretty straightforward. The way that these things communicate, I mentioned there's basically 3 types of messages that you want to send within your system. There are commands, queries, and then events, right? And so you can use the mediator library if you like for any of those. You could use mass transit for any of those. If you're going to move from a modular monolith where everything is in process and everything is in memory, you may want to start with mass transit because it has an in-memory support, but then you can easily move to using RabbitMQ or some other persistent storage under it. What you probably don't need, and what I've seen asked a lot is, do I need to have a message bus to build a modular monolith? And I think the answer is no. What you would counter-argue with is, but wait, how do I make sure that if something goes down that I still have that operation? It's like, well, how do you do that between method calls now, right? Like it's all in memory, right? Just because I'm using mediator to pass between the projects, that doesn't mean that I can't still just step through the projects or step through all the lines of code and see, how it's processing as a single thread through the system. And so, it's okay when your system gets, shut down today that it's going to get the rug yanked out from it right in the middle of a process. And that's no different when you modularize it. So if you're not, building, RabbitMQ or something as a backing store for every method call you do today, you probably don't need to do it when you modularize it either. But you might want to use mass transit just so it gives you an easier path to a distributed system in the future. All right. Does anyone have questions about this organization? And then I'll talk about the reports in a second. Yeah?
How are you sharing model objects? Are you putting them in contracts and just using the contracts, or how do you manage that?
Sure, good question. So the question is, how do I share model objects? And for me, when I'm thinking model objects, I'm thinking domain model stuff, and that should be encapsulated. So I'm explicitly not sharing that. Instead, what I am sharing, like you mentioned, is stuff in the contracts. So if I need to know stuff about a book, I have a book details response DTO that comes back from a query, and it'll tell you what you need to know about that book. There's a few other patterns that you can use. If you have stuff where 2 modules are constantly talking to each other about stuff, you'll find this in microservices a lot as well. That usually is an indication that should be one module, right? And you can bring them together. But if you don't want to or can't or have good reason why it shouldn't happen that way, there's other patterns you could use, like a materialized view pattern. And what that is basically you have one module or microservice that has essentially a copy of all the data in it. And then when the request comes for it, instead of it going out to the source and actively going and saying, hey, give me this book, right? It already has it, and it just looks at its copy of that. Now, that's basically a cache. Right? And of course, the problem with caches is they can get out of date. So what you do to keep that distributed, or I'm sorry, what's the word I just used? Materialized view up to date is it's listening for events from the source. Right? So regardless if it's a microservice or it's a separate module, right, the source of the data is firing off events to say, book changed, book updated, book inserted, book deleted, and your materialized view is listening for those and keeping its thing up to date. Does that answer your question? All right, great. Let me talk about reports for a minute. There is a very common anti-pattern in microservices and apps in general, which is called the reach-in reporting anti-pattern. And there's a nice book chapter about this for free on O'Reilly's website. And so what happens is you've got a few microservices, maybe you've got customers and orders, and somebody wants to have a report that says, well, which customer had the most orders last month? And so you go write a query that joins those 2 things, or well, let's just say we'll start with that, right? You write a query that goes and talks to both databases, or maybe they're on the same database because you didn't do microservices right, and then you generate that report. And that's great until one of those microservices wants to change how they model that stuff in their own database, and now your report breaks. Right? And the people that want those reports are usually higher ranking than the people that are maintaining those modules. So it's more likely that like you can't change your model, right? Because something else depends on it. And so you get stuck, right? Now you're in a position where you can't update the model to reflect what it should be. And so it's a kind of technical debt where you're living with workarounds because you've locked in the schema. So another approach could be that you have some process that's running and is going out periodically and grabbing the data from those tables and building up a separate data lake or reporting database, right? And then it only queries that. Right? Now the good thing about that is that now you've solved the problem of when somebody runs the report, it doesn't block all those tables and make it so it's slow for anyone to try and purchase anything because these big reports are running. Right now they're running against their own database, so that's great. But you haven't really solved the problem of coupling, because the reporting data fetcher still knows about the schema and can actively talk to those databases. And there's a story I like to tell about another consultant who was running into this and was building stuff for a client. And he told them, like, I'm going to build this system, but it needs to be isolated from all the other things. Nobody else can query it. And of course, everybody else has system admin access to that database at the client. So that didn't last long, and they said, oh, there's this new database. I wonder what I can get out of there, right? And so he sees other things are connecting. And so he wrote a script that would basically, when his app started, I think it was each day, right? Each day, the database name would change, like the actual name of the database, and his app would update its connection string. And so his app knew the algorithm that he was using. It was some pseudo-random thing that was predictable for him, but nobody else knew that. So like, no, you can't talk to my database, right? And so if you do that, then you'll have better modularity. It works. It's great. The right way to do it, though, I think, is again with events. Right? So if you need to know about orders and customers and things in your reporting system, then you should just be firing off events from those systems. The reporting system is listening for those events. You're loosely coupled because now you're coupled to the contract of that message. And so yes, if you suddenly completely change what that order created event looks like, you'll break the reporting system. But probably you're going to coordinate with them before you do that, right? And it's much easier for you to break that contract in a scheduled, versioned way than to say that you can't ever change your database schema because other things might be using it. It makes it much more easy for you to change your representation of your own stuff in your module. All right, so that's what happens in here inside this reporting module. Every time a new order is created, there's this integration that reads from that and basically ingests the new orders that are coming in and pulls out their items and does some other things. And then when it's done, it just calls this add or update sales, and in there, somewhere there's a order ingestion service. Let's just go to implementation. In there, it's just doing, in this case, raw SQL to update stuff. And so once again, if raw SQL is the thing that makes the most sense, you can do that in some modules if you want, right? You don't have to use the same ORM or data access or even database in between modules. And so for whatever reason, I just want to demonstrate that you can do it, here with, I think I'm using Dapper in this case, I want to say. Yeah, so another micro ORM instead of using Entity Framework Core. It doesn't matter. Every module can make its own decisions about what makes the most sense for it. And so what this is doing is it's writing to a separate reporting database. Every time there's a new order, there's an event that's fired, and this thing picks it up and it puts it into its database. And when I need to write a report, the actual report is super simple because I've put everything already into a table that's formatted as the report wants it, right? So there's no massive join of trying to figure out how to get all the data. It's just like I'm building up the report continuously, right? And you can do stuff like star schemas and other things to make that very flexible and basically design your reporting database for reports rather than using a transactional store as your reporting database. All right. Let me jump back to slides for 1 second, see what else we had here. So the thing about monoliths is that oftentimes they don't have any of this modularity. They only have layer separation, which is not sufficient. Microservices can solve this problem. They force modularity on you, which is one of the nice features of them, but they have a lot of downsides and they can be overkill for your needs. If what you're just going for is modularity, go for modularity in your monolith first before you try and achieve it in a distributed system. And so I think for many enterprise, business to business, internal systems, right? Modular monoliths make a lot of sense. I think if you're Netflix, right, you probably want to build something that's a bunch of microservices, as they do. But there are plenty of things like GitHub or Stack Overflow or Shopify that all run as monolithic architectures today, right? So it's not like you have to have microservice architecture to build anything that has any kind of scale, right? Monolithic applications work fine in very many scenarios. If you want to learn more about it, this is the course, and then I've got like 5 minutes for more questions, and I can dive into specifics in the code if you like. So any questions? Yeah.
So you talked about restricting how different modules depend on each other, that they can only talk to each other through the events. Is there a way to actually automate that more than just like sending an email saying, please don't do this?
To automate the restriction.
The restriction, saying
Yeah.
these modules can't directly talk to each other. They only have to.
Yes. The best way to do that is, well, one, you do pull requests and code reviews, right? And just don't let it get by. But if you want to enforce it, you can do tests. There's a library called ArcUnit for architecture unit tests, and there's ArcUnit comes from, I think, Java. ArcUnit.net is the .NET port of it. But basically, it'll let you write tests that say something like, types in this namespace should never depend on or reference types in this other namespace, and so you can do that. The other thing that I showed is that you make everything internal. I'm not sure I called that out, but then the compiler won't even let you do it either, right? So in books, right, the main entity, the main data type here is an internal class, so no one can get to that outside of that project.
You want to have like some things can depend on like parts of this library, but just not this specific library can depend on it.
Sure, and ArcUnit would work for that. If you have specific things, just write a test for it, run that test as part of your CI/CD pipeline, and you won't catch it immediately, like at compile time, but you'll catch it at test time at least. Other questions? Yeah. How do you wrap commands to two separate modules in a single transaction? You generally don't, right? It's the same answer as microservices. If you really need to, and you are using the same database with just different schema, you can, right? And so maybe if you really had to do that, I'd probably put it in its own project that was like, able to break the rules project, and maybe use raw SQL or something and do it there. Because sometimes you really want that capability, and if you are using the same database, you certainly can have a transaction, but it should be an edge case. It should be a special thing that is not the routine. Yes, sir?
What code, if any, would you want to share between models?
What code, if any, would we want to share between modules? Well, okay, let me talk real quick on that. So let's go to, which one was it? Users one again. So in the users module, I briefly talked about how there was an endpoint for doing the cart, and then there was this use cases folder, and it has this checkout handler. And I didn't really explain why I'm doing that. And some of you are probably thinking, why are you wasting your time with that? All that code could have just gone in the endpoint. And you're right. And I often would write code like that. But the thing that has led me to doing this approach, where I'm using a handler for each one of, I'm calling them use cases, but each one of the essentially features or endpoints coming in, is that I can create a pipeline of my own, right? Just like the middleware pipeline that you have in ASP.NET Core, I can create my own pipeline that's using a design pattern that's kind of like Decorator, but it's the chain of responsibility pattern. And it's the same exact way that middleware works, right? So in here, because I'm using a handler, Mediator has this notion of things called behaviors. And so in here, I've got a logging behavior, which is a pipeline behavior, and it will do some simple logging here of saying I'm handling this request, and it has these parameters, and it took this long. And so it'll say when it started, and then when it's finished, it'll say, here's how long it took. And then I can also do validation. So I can have another one that's in that same pipeline that's doing validation. And so now I don't have to write logging code in my handlers. I don't have to write validation code in my handlers, right? It's all these cross-cutting concerns you just put in your pipeline, and it flows through and it gets all those. So anything that you have that's cross-cutting like that, whether it's validation, caching, logging, et cetera, maybe error handling in some global manner if you're not using the default ASP.NET Core stuff, right? You put all that in here, and then that stuff is in shared kernel, right? You might also have base types, right? So all my domain events I'm using, the base domain event is in shared kernel. All the modules share that. You don't have to, but if you find things that are useful like that, that's how you would share it. That's the things that I am sharing in here. Good question. I got like 2 minutes. Any others?
There was a comment I saw that said possibly replace mediator for performance reasons.
Yeah, so inside of, I don't know, is the cart create the order thing, right? Which was like here. And the reason why you would want to do that is, again, just to reduce how much work you're doing in the request. Like, again, I think like if you're Amazon and you want to just finish this as quick as possible and return back the request, rather than going and sending this to the other thing, that's not the overhead. The overhead is that the handler for that's over in the order module is going to actually go to the work of creating an order and saving it to the database, which doesn't sound like much. And I think it also sends an email, right? It's doing all that stuff like while the request is waiting, it's writing to the database, it's sending emails, it's doing other things. Whereas if I just put this on a message queue right here, right now, message queue writes are like super fast, faster than databases. And so I can just drop it on a queue and then exit, right, and be done. And then something else will quickly pick up that queue and handle it. That's all I'm saying. Does that make sense? All right. Anyone else? All right. Well, thank you very much. And I will see you later. Thanks.